Good afternoon. Today we are working on math packet number 6. So we are looking at our ways to work out these different problems. Our first page is one of our word problems. When you fold a square paper, the resulting rectangle has a perimeter of 39 inches. What is the perimeter of the original square? So we're going to look at this and we're going to say, well, I need a square. So I know that a square, each side is going to be the same size. And I know that it is a rectangle has the perimeter of 39 inches. So I need to think this through logically on how this is going to work. So we could come up with some numbers. Like, let's say, I'm going to guess if this was 15 and this is 15, and this would be 15, right? So 15 plus 15 is 30. Well, and I know that it's 39 inches, so I need 9 inches on the sides. So this half is 4.5, and then this half would be 4.5, and this would be 4.5. Why is this not the right answer? Alexis?
Because if you add up the two 4.5s, they don't.
Yeah, because it's a square. That original shape is a square. So this side must equal this side. Okay? You're going to have to do some guess and checking to see which numbers to use for the rectangle. And then when you move it up, that it's going to make a square. And both sides are going to be the same number. So it's going to take some guess and checking. There's no magic solution to doing this one. You will have to guess and check to make sure that each side is equal. And when it's cut in half, this side plus this side plus the two long sides equal 39. So this one's not a quick and easy one. You have to think it through a little bit, and you might have to redo it a few times. Let's look at our next page. Tom has 4 different colored shirts, yellow, orange, blue, and red. He has 4 pairs of shorts, brown, black, green, and purple. How many different outfits can Tom make? It's not asking how many different outfits will look good. It's saying how many outfits can he make. So we need to figure out how many combinations all together. So what I did was I said, okay, yellow, orange, blue, red shirts. I could have a yellow brown shorts. I could do a yellow shirt with black shorts. I could do a yellow shirt with green, and I could do a yellow shirt with purple. Okay, those are all my combinations I could have with a yellow shirt. I'm gonna have to do the same thing with my orange and with my blue and with my red, and I'm gonna see how many possible combinations there are all together. So you need to show your work. You can't just write an answer. You have to show how you did it. Some of us are going to show it by writing out all the possible combinations. Some of us know the equations to do already. Okay, we haven't covered that in class yet, but we will be. Make sure that you are showing why it makes sense. Don't just write answers. We know how to do our 5-card challenges. There is a 2. So, if you want to square a number, we have the 2 in there, so we can use squares, and we can use square roots because we have that 2. Something to keep in mind. For our pattern, we need to find the pattern to complete the table, and then to go down to the 15th figure. What I was explaining to one of our classmates last week was that sometimes it's easy to find the pattern, and then the challenge is to find the rule. So if I'm looking down at geometry and I say, ooh, how do I get to that 30th figure without following the pattern every single time and writing it out all the way down to the 30th? There is a rule that you will find that will work. This is not an easy one to find the rule for. It will be challenging. Sometimes it's easy to find that rule. So I could say, well, what's the 75th figure going to be? And you could say, oh, I can plug in the numbers into my rule and I can tell you without having to follow that pattern. This one is not an easy one for that. So you're going to want to just look at one figure. First figure has 1 block. Second figure has 3 blocks. Third figure has 6 blocks. Fourth figure has 10 blocks. Fifth figure has 15 blocks. See if you can figure out that pattern, how it's increasing. You don't have to do the geometry. That's not until you're in 8th grade. Pattern is one thing. I'm saying rule. You don't have to find the rule until you're in geometry. All right, next page. Finding the pattern is pretty easy. Finding the rule, not easy. Next page. Oofda. Surface figure. You have to make your net. And everybody's going to want to write this down because the formula for the surface area of a cone, it's a lot to it. So here is the formula for the surface area of a cone. Surface area of the cone equals pi times the radius. And then we're going to have a whole lot in parentheses. We have the radius plus the square root of the height squared plus the radius squared. So it seems complicated, but we know how to find these numbers and we can use a calculator. So we're just going to punch it all into our calculator and it's not going to be as complicated as what it first looks like. We know our height is 19 and our radius is 5. And on your calculator, you can either use the pi button or we know that pi equals 3.14. So we're just going to punch it all in, that equation into the calculator, and it's going to do the magic math for us. Priya.
Once you figure out like all the stuff in the parentheses, do you times that by pi times y?
Yes. So you do the parentheses first, order of operations Perm does. I would do the h squared, so 19 squared plus 5 squared, and then I would take the square root of that, and I would add it to my radius of 5. So I would take that answer, and I would multiply that by the radius by pi. Okay, so you want to do the square root first, radicals first, Perm does. Your squares and then your radical, then add it to 5, and then multiply by that. Yes, Audrey.
How do you do like the biggest square? Yeah.
On your calculator, you have the square button. So it's where it says x squared. If you look on the, here, let me, so if we look on our calculator, to square a number, let's say we do 7 squared, we press this button, and then equals 49. To find the square root of it, we do the opposite. We go up to the second, and we press that same button because we see that square root symbol on the calculator. Oops. Sorry, we do the square root first, then you put in the number that you want to square. So you do the square root symbol first. So second, so the square root. Then I put the number that I want to find the square root of. And then you hit equals. So the square root of 49 is 7. Okay? So you're going to want to find the height squared plus the radius squared. Find that. Add it to, and then find the square root of those two that were added together. Then you're going to Yeah. Then you're going to add it to 5. And then you're going to multiply it by the radius. And then multiply it by pi. So it's a lot of steps. But is it hard? No, because we have the calculator to do the math for us. So we just follow it one step at a time. Aiden.
I'm confused at the order of how you do it. Yeah.
First thing you're going to want to do is do 19 squared plus 5 squared. So you're going to want to find that answer. 19 squared plus 5 squared. Then you want to take the square root of it. And then you're going to add it to the 5. Then you take that answer and you times it by the pi and the 5. So just work it backwards.
So are you multiplying the pi and the 5?
Yes. Gus.
Do you round to the nearest hundredth of the answer?
I did round to the nearest hundredth, yes. Okay, let's look at our next page. Now we have the volume of a cone. So you're going to want to write this down. So I know some of you are still working on the surface area. You're going to stop. We're switching to the volume. The volume of a cone. We know the volume of a cylinder is pi r squared times the height. So a cone is taken out of a cylinder, and the cone has that triangle in it, so it's height divided by 3. So you're going to do pi times r squared times a height divided by 3. So if we are to write out that calculation, we have pi, which is 3.14, times r, which is our 7 squared, times our height of 18 divided by 3. So 3.14 times that r of 7 squared times our height divided by 3. That answer you're going to put right here. Now for this one, it says a Pre Algebra says a cone has a volume of 131 meters cubed with a radius of 5 meters. What is the cone's height? So we're going to take our formula of pi, and we know our r is 5 squared times the height we don't know divided by 3 equals 131 meters cubed.
Wait, is it 18?
Nope, because we're going with here. This is different than that. So it's a different cone. So when you dig down to this one, we're doing a different cone. So we need to use the numbers that it gives us, and we're going to solve for our height. So it's doing those opposite operations.
Did you guys use your calculator and it?
Well, can we do that when we have an unknown in the middle? No. So you're going to want to find out what this is. And what are we going to do with that information? Evelyn?
Use it to figure out H.
How?
Because you're going to take 181 squared.
If this is multiplying, what's the opposite? Dividing. So we're going to divide that into 131. Then we have H, our height, divided by 3. What's the opposite operation, Emily? Multiply. So we're going to take this answer and we're going to divide. Then we want to get H by ourselves, so we're going to multiply that by 3. So we're just doing those opposite operations that we know how to do. Okay, I'm going to come back to this one. So if somebody has questions on this, we can come back. Was it a quick, easy?
Yeah. Like if you end up with like some big decimal on your calculator.
Rounding to what? What did I say we're rounding to on the last page? To the 100th place. Rounding to the hundredths. Okay, so your answer, you're going to round to the 100th. All right, next page. Oops, turned it the wrong way. We've been working with circumference and area of circles. Yeah, the last like 2 math packets have had this. Mm-hmm. So remember, for the circumference, that's the perimeter of the circle. The circumference is 2 times pi times r. It's a semicircle. So do we need to multiply it by 2? No, because we want half of the circle. So you could multiply 2 times pi times r, which our diameter is 7. So what is our radius? Half of that, 3.5. So our radius is 3.5 times pi. And we only want half the circle. So we're going to be dividing it by 2. So we don't have to multiply it by 2. Because we just want the half of it. Perimeter, remember, 5 plus 5, the outside, plus the circumference.
Excuse me, just for a few good announcements. Beginning quiet meets after school until 2:30 p.m. We have 2 games tonight. Boys B Squad versus 4th Baptist at home at 6 p.m. and Varsity Gold versus 4th Baptist at home at 7:15 p.m. Have a good afternoon, everybody.
Okay, to find the area of the circle, it's pi r squared, but we want half of the circle. So we're going to want to divide it by 2 because it's a semicircle, it's not a full circle. So to find the area of half of this circle, you do our formula pi r squared, but divide it by 2. So this is the area now. Circumference plus the perimeter of the square. That's your perimeter. Circumference plus perimeter. Now for the area, you want half of the area of the circle plus our area of the square part, which would be length times width, right? We don't have to do. Yeah, we do have to divide by 2. So length times width needs to be divided by 2 because it's just half of the square. Thank you, Evelyn. Yes?
I'm confused.
Which part? The perimeter or the area?
Both. I don't know, like, how do you get the area and perimeter of the triangle?
So if we have a square and we cut that square in half, if our square was 5 and 5, we could cut it in half, right? And it would be this shape. So we can find the area of the full square and divide it by 2 because that triangle is half of the square. Okay?
So it's just 5 times 5.
Yes. Did that make sense?
Yeah.
Okay. Let's move on. And if there are ones that are not making sense, we can work it through. We have until January 24th when this is due. Okay, for this one, we need to decide if our dot is inside or outside of the figure. So if we look at this first one, our dot is right here. I'm going to go and look and say, can I get my dot outside? Tracing it through like it's a maze, and there is no path that gets me outside. It's blocked. So it is on the inside. So I'm just going to mark it as the inside. Here, I'm going to follow my dot, and I'm following it around. Oh, I'm able to get out. So that means my dot is on the outside. If you can trace your dot all the way through and come out, that means the dot is on the outside of the figure. So you're going to do the other 3 on your own. They're a little bit more complicated. I use the easy ones as my samples. So you're just going to find where the dot is and see if there's a way that you can make it to the outside of the figures.
Are we supposed to do the one on the top right? Where that's all.
There's no dot on that one. This one are you talking about?
Yeah.
There's no dot for that. It's just showing a figure. So that's not an exercise that you have to do. You have to do the 5. The smiley face, this, that one. Polynomials, we know. We have those on all of our packets. The last page. I've had a lot of us asking me questions about this. You need to find what the pattern is for the first section, and then you need to follow that pattern for the second. So if I look here to go from a triangle to a triangle inside a square, what would that pattern be? I have the triangle has 3 sides, and it's inside a 4-sided figure. Pentagon has 5 sides. What kind of figure is my pentagon going to be inside, Aiden?
No.
A hexagon has 6 sides. So if we look, 5-sided figure inside what? We have a triangle inside the square. So my pentagon has to be inside. This one, the pentagon's not inside. This one, the pentagon's not inside. This one, that pentagon is inside the hexagon. So you have to see what the pattern is on this side and say, okay, now I need to follow that same kind of pattern to see what my answer is going to be. So all you have to do for this is circle what is going to come next in the pattern. So it's not a pattern 1, 2, 3, 4. It's a pattern of 1, 2, 1, 2. Like, what is going to come next if I have the same pattern? So it's all about patterns. Is that making sense?
Yeah.
Each one has a different pattern that it's following. So think about what pattern.
I don't get the second one.
This one?
Yeah.
So 360 is how many degrees? Oh, sorry. A circle is how many degrees? A circle is 360 degrees. So now we have this shape. Is that shape 90 degrees? Is that shape 100 degrees? Is that shape 120 degrees? So think about how many degrees that would be. And with that, I'm going to stop the recording. So if you are listening at home, we hope you are well and hope to see you soon.